Hey guys, so welcome back. This lesson today is how you can sketch a graph of the derivative of function f prime. So if you have a graph of f, how can you use that to draw a graph of f prime? So here's how we want to think about it. The slope of f, the slope of our original function, is the value of your f prime. So if you're thinking about a graph, the slope of your f graph is like the height of your f prime graph. So what I mean by that is like, well, let's see. If f has a positive slope, then that means that your f prime is positive. And if we think about like when is a function positive, it's positive when it's above the x-axis. Okay, and of course the opposite of that, of course, is true as well, is that if f has a negative slope, meaning your f prime is negative, then that means that f prime is negative, which of course means you are below the x-axis. Okay, so that's the idea, and we're going to talk today about like various different types of graphs of f and how you can use that to kind of sketch the graph of f prime. And some of this is going to be approximate, and some of it I think will turn out pretty nicely. So let's go ahead and look at, I think, several examples. First off, we'll start with straight lines. So suppose we just have this function, okay? So you just have like that. Okay, so here's an example, and what I'm going to do is on the graph of f of x, I'm going to do that on the left, and all my graphs of f prime of x, I'm going to do those on the right. Okay, so what is going on? Well, again, this is a graph of the slope of f. And hopefully you take a look at this graph of f and realize this graph has a constant slope, right? Every single point along here has the same slope. It all has a slope. It just goes up 1. So the slope is 1. Now remember, if it has a constant slope of 1, the slope of 1 means that on my f prime graph, it's going to have a height of 1. No matter where you pick, that f prime value is always 1. And this makes sense, right? Because if you think about equations, this is the function, this is the function x plus 1, which has a derivative just of 1. So that's why this makes sense, that we always have a slope of 1 there. Okay, so let's look at another straight line that might have a few more points. And again, let's take a look here at a graph of f on the left and f prime on the right. Okay, so what this graph is going to look like, up until here, we're going to go with a slope of 2. You can see the rise over run here is 2. It's just poorly drawn. And then from 0 to 3, we're going to have a slope of 0, just a straight line. And then we're going to have a slope of -1 the rest of the way, again, poorly drawn. Okay, from like a sharp corner right there. Okay, so let's think about this, right? Again, we're breaking this into 3 different parts. Everything comes back to these piecewise functions. So the first part of this has a slope of 2. So if it has a slope of 2, that means your f prime is equal to 2. So up until 0, it has a slope of 2. I'm going to draw open dots on all of these simply because that slope is undefined, right? If we look at there, there's no clear slope at that point. It's not defined. It doesn't exist. Kind of the limit is different on both sides. If the limit is different, it doesn't exist. So then we have a slope of 0 from x equals 0 up to x equals 3. So my f prime there is equal to 0. And then on the last part where we have a slope of -1, well, remember that the slope of f is the height of f prime. So that means here, if your f prime is equal to -1, for that section, again, we'll just do open dots everywhere. We're going to have a slope of -1 like that. Okay, so that's how you draw your f prime graph. So those are all cases where you have a straight line. But the next question that obviously you're thinking about is what if you have something with curves? And what we're going to be doing here is trying to approximate an f prime graph. Without an equation, it's impossible for us to draw a precise graph, but we're going to try our best. Okay, so again, we'll draw f on the left and f prime on the right. Okay, so what if we just do something simple? So what if I just have like a parabola that looks like this? And here's what I'm going to start with. The thing I'm going to start by asking myself is first, where does f prime equal 0? Why did it do that? Where does f prime equal 0? And that's going to be my starting point anytime I'm drawing a graph of the derivative. So I should look and say, okay, here's a point where I have a slope of 0. So I'm going to draw, okay, if f prime equals 0, that's like my y is f prime. So that's like, where do I have a height of 0? Right at the origin. Okay. And then what happens, right? Like, now after that, I want to think, where is f prime positive? So where do I have a positive slope of f? And then, of course, the opposite, where is f prime negative? Where do I have a negative slope of f? Okay, so if we look on the right side of the graph, right, we have a positive slope in here. This is where my first derivative is positive. Okay, so we have a positive slope to the right, and then on the left side, let's do a different color here. On the left side, we have a negative slope. I'm just color coding to try and make it clear. The other questions you might want to ask yourself is like, is it getting steeper? So is the f graph getting steeper? In which case your f prime is getting more positive. It's getting, like, we're not going to have the same thing that we saw above, right? Where we see like a constant slope for a wide interval. We don't have that, right? The slope is changing. Okay, so to the right of this, we have a positive slope. And if we have a positive slope, that's just where we're above the axis. If we have a negative slope, if my f prime is negative there, I have a negative slope, that's where I'll be below the axis right there. Okay, so I'm using that 0 as starting point. I have a negative slope kind of going up towards it. And then on the right side, it looks like I have a positive slope. And as we go over to the right, we see the slope is getting steeper, right? It starts out pretty flat, and then it just gets steeper and steeper as we go. So maybe something like that. Okay, and maybe this is curved. Maybe you just kind of made a straight line. That's up to you. That looks really terrible. But maybe you made a straight line. I'll see if I can do that a different color. Like, that's another option. We don't have an equation, so we don't know if exactly it's a straight line or curve. So either one of those would be acceptable. We're mainly looking for positive, 0, negative, that sort of thing. Okay, let's do a couple other examples where we might see something like this. Let's do one that's like a little more tricky here. So what if we have a better picture? What if we have something that looks like that? All right, and then we're going to have a curve that comes in and goes whoop, whoop. And then we're going to get back to a 0 slope there. I did not draw that part well. Okay, we're going to get back to a 0 slope at x equals 0. And then we'll go down here and do a big little shoop-de-whoop and go up again like that. Okay, and then how do we go ahead, and again, this is a graph of f. How do we draw a graph of f prime? And again, I want to encourage you guys, start where f prime equals 0. And then basically you're just looking between each point where f prime equals 0, are we negative or are we positive? Okay, so we see at -3, at 0, and at 4, because we have horizontal tangents at each of those 3 points. If you want to like pause the video and draw your own graph, that might be a good idea, just gonna guess. Okay, so we have a 0 slope at 0, at -3, and then again at 4. Okay, well, to the left of this here, we actually see a negative slope, right? It's going down until I get to a slope of 0. So my f prime is negative there. So I have a 0 slope going up there. All right, on the next section, from -3 to 0, we see a positive slope. So we started a 0 slope at -3, and then we go back to a 0 slope at 0. But in there, we certainly have a positive slope, right? We're going upwards. So that means we're above the axis again. My f prime is positive. I'm starting and ending at 0, so that kind of pigeonholes me, but I got to start at 0, go to positive, go back to 0 like that. And then I have a negative slope the rest of the way like that, back to a 0 slope again. So anytime I have a negative slope on the left, it just means that I'm below the axis down here. So I have a negative slope from the 0 back to the negative. Again, who knows how far down you're going? We're really just estimating, like, maybe you went down to -3, maybe you went down to -5. It doesn't matter. We're mostly really just concerned about the general shape, not how far down you're going. And then the left side, or the right side of the graph, we start with a 0 slope, and then it just becomes more and more positive, and then goes up looking like that. Okay, so that's the general idea of how you do this. Hopefully this kind of makes sense, because the answer on the left kind of looks like an x to the 4th graph, and this kind of looks like some kind of x cubed graph, a cubic function. So that hopefully makes sense. If you have questions, please feel free to send me an email, and thanks for watching. I hope this helped you guys.